friends. So in this class we'll discuss about constructional details of DC machines. So here constructional details are common for both DC generator and DC motor. See, see here. This is stator. This is stator. This is stator. This one is base. This one is base. So why are using base? Base. See, this is base. This is base. So DC machine stator placed on base. Placed on base. So why are using base? Base which gives support to stator of DC machine, which gives support to stator, which gives support to stator. And this one is stator yoke. This one is stator yoke. This one is called yoke. Stator yoke. Clear? Next, this one is pole core. 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 This one is called pole core. This one is called pole core. So what is the function of yoke? Which gives support to pole core, which gives support to pole core, which gives support to pole core. Next, this one is pole shoe. This one is called 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 pole shoe. See here, what is the function of pole core? Which gives support to pole shoe, which gives support to pole shoe. See here, field winding placed on 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 pole core. Which type of supply given to the field winding? DC supply. Which type of field supply given to the field winding? DC supply. This is DC supply. So if you give DC supply, what happen? Whenever the constant current passes through the coil, what happen? Constant magnetic field is developed. Constant magnetic flux lines are developed. So these flux lines are moving from, see, North Pole, South Pole. So here flux lines are moving from North Pole to South Pole, North Pole to South Pole. So here flux lines are moving from North Pole to South Pole, North Pole to South Pole. Here this is the, sorry, this is the direction of magnetic flux line. This is the direction of magnetic flux line. So flux lines are passes from North Pole to South Pole, and it is closed by yoke. So this flux passes through yoke, this flux passes through yoke, and again join to North Pole. Similarly here flux lines are passes from North Pole to South Pole and South Pole to North Pole through yoke, North Pole through yoke. So here return path provided by the yoke. So what is the function of yoke? Which gives the support to pole core. That is first point. Here yoke which gives support to yoke. That is first point. Second point, which provide path for magnetic field, flux line, which provide closed path for magnetic field, So this is flux line, Clear? See, here what is the function of pole shoe? Which pole shoe is attached to pole core, and here this one is chamfering, Why the pole shoe is chamfered? Because to get sinusoidal waveform, and the air gap between pole shoe and armature conductor is very small. See, here I will place rotor. See, what is the rotor? This is rotor. This is rotor. These are the rotor slots, armature slots. These are the armature slots. Armature slots. So here in armature slots, what we will place? Armature conductor. See, this gap is called armature slots. This gap is called armature slots. This one is called armature conductors. This one is called armature conductor. So armature conductors are placed in armature slots. This is rotor shaft. So here prime mover is attached, and if it is rotating, rotor is also rotating. If rotor is rotating, armature conductors are also rotating. So this is about constructional details of DC machines. See, what is the function of base? Which gives the support to yoke. What is the function of yoke? What is the function of yoke? What is the function of yoke? Which gives support to pole core, which gives support to pole core, and also provide closed path for magnetic field developed in the field coil. Also provide closed path for magnetic field developed in the field coil. And what is the function of pole core? Pole core, which gives support to pole shoe and and which also provide accommodation for field winding, which also provide accommodation for field winding. And pole shoe, which is attached to pole core and which gives sinusoidal, means uh, the air gap between pole shoe and armature conductor is thin, so almost provide sinusoidal flex, almost provide the air gap between pole shoe and armature conductor is very thin. Uniform flex it can provide, uniform flex. See, next, this one is armature. Armature slots, armature conductors are placed on rotor. Armature conductors are placed on armature slots. So here, whenever the flux cuts to the rotating conductors in DC generators, what happen? EMF is induced. That EMF can be collected by the brushes through commutator. But in DC motor, same armature conductors are rotating, same armature conductors are current carrying conductors in DC motor. In DC generator, we are giving mechanical input, so that rotating conductors. So in case of DC generator, these armature conductors are rotating. In case of DC motor, these armature conductors are current carrying conductors. These armature conductors are current carrying conductors. So this is about constructional details of DC machines. Thank you.